Hello everyone. Welcome back to SHR Trinity. In our previous video, we learned the fundamentals of one-shot prompting. Today, we focus on a highly critical aspect for developers, formatting. In this video, we will explore how to use one-shot prompting to enforce strict JSON, XML, and structural outputs that are essential for API integrations and enterprise applications. Before we dive in, if you're looking for practical, industry-oriented training in artificial intelligence and generative AI, SHR Trinity offers a comprehensive 30-hour training program. For complete course details, check the description below. Now let's begin today's interview session. We will now continue our series with 10 questions focused entirely on formatting and structural adherence. Moving on to our next question. How do you use one-shot prompting to prevent an LLM from adding conversational padding like, "Here is your output," before a JSON response?
Hello everyone. Let's talk about one of the most common frustrations when working with large language models in production: conversational padding. By default, LLMs are trained to be helpful chat assistants, which means they love adding phrases like, "Sure, here is your JSON response," right before giving you the actual data payload. If you are building an automated API pipeline, that extra text breaks your JSON parser immediately. Now, while you might try adding system instructions like "do not include conversational text," models often ignore zero-shot system prompts under complex conditions. This is where one-shot prompting shines. By giving the model a single concrete example where the prompt input leads directly to a clean output that begins with an opening curly brace and ends with a closing curly brace, you set a strict mathematical pattern for token generation. The model looks at the structural context of the example and mimics that precise lack of chatty text. For instance, consider our example where we feed the model the input apple and show an output of raw JSON string, fruit, apple. When we follow up with the actual task asking for banana, the model skips the pleasantries entirely and outputs strictly, fruit, banana, because the visual example anchored its output distribution. Incorporating a single zero padding example guarantees output reliability far better than text instructions alone.
Moving on to our next question. If you need a model to return a specific nested JSON structure, why is one-shot prompting safer than zero-shot?
Welcome back, class. Today we are addressing how to enforce complex data schemas when extracting structured information using LLMs. When you need a deep, multi-level nested JSON object, say, 3 levels down with arrays and dictionary fields, relying on zero-shot prompting is risky. You can write a lengthy paragraph explaining that preferences should be an object containing subkeys for theme and notifications, but models will frequently flatten that dictionary or hallucinate brand new key names altogether. One-shot prompting is significantly safer because a concrete code snippet acts as an absolute structural blueprint. The attention mechanisms in the transformer architecture visually map out the exact key names, structural depth, and list formats from the example directly into the generated output. Let's look at how this works in practice with our example. Imagine you want the model to extract a user profile. In your prompt, you include a single example showing a root JSON object containing a nested preferences dictionary alongside an interests array populated with strings. When you feed in new unstructured text, the model doesn't have to guess what nested object means. It simply replicates the visual schema provided in the example down to the exact nesting depth. As a best practice, make sure your single example includes all possible structural keys so the model understands the full data contract. This simple technique virtually eliminates schema syntax errors in downstream code.
Moving on to our next question. How can you use one-shot prompting to enforce data types, like ensuring a price is returned as an integer instead of a string?
Let's dive into data engineering with LLMs. A fundamental challenge developers face is that language models generate text strings, whereas our software applications expect strict data types like integers, floats, and booleans. If your Python code expects a price to be an integer for mathematical calculations, but the model outputs price, $1,200, as a string, your script will crash. Zero-shot instructions like return price as an integer work sporadically, but one-shot prompting fixes this completely through pattern completion. Language models don't read abstract type definitions, they copy syntax. If you show the model an example where the numeric value lacks quotation marks, the attention mechanism recognizes that digits following a colon without quotes represent the required syntax pattern. Let's walk through our example to see this in action. In the prompt example, we explicitly provide an output object featuring item, laptop, price, 1200, in_stock, true. Notice two critical choices here. 1200 has no quotation marks or currency symbols, and true is a lowercase unquoted boolean. When the model processes a new product description, it follows this exact visual template. It casts the price directly as an unquoted integer and the stock availability as a proper native boolean value. This ensures seamless parsing directly into your database or application context.
Moving on to our next question. What is the role of Markdown syntax in structuring one-shot examples?
Class, today we're discussing visual boundary markers in prompt design, specifically Markdown syntax. When building automated AI workflows, isolating prompt instructions from example outputs is crucial. If you don't clearly demarcate where your text instructions end and where the structural example begins, the model can get confused and mix prompt text into the final output. Markdown syntax, especially code blocks created with triple backticks, serves as a powerful boundary layer. When you wrap your example in triple backticks, for instance, using triple backticks with a JSON or XML language tag, you are giving the transformer model a distinct contextual fence. The model recognizes the sequence as a code container and learns that its output must also be wrapped inside matching backticks. Let's look at our example using XML. If we want XML output, we wrap our example response inside triple backtick markers tagged with XML. Step by step, the model observes this structure. It sees backticks, reads the XML tags, and sees the closing backticks. When generating the actual response, it repeats this wrapper pattern perfectly. The major developer benefit here is reliability in production. By forcing the model to wrap its answer in a standard Markdown block, your backend code can use a simple regex expression to extract the raw payload from the API response effortlessly.
Moving on to our next question. Can you use one-shot prompting to enforce a specific table format in the output?
Let's explore formatting text outputs as tables using one-shot prompting. When asking an LLM to tabularize messy data, relying purely on text prompts like "format this as a 3-column table" frequently fails. Models might generate plain tab-separated lists, omit headers, or dynamically invent new columns mid-output. To guarantee bulletproof, renderable table formats, we use a single Markdown table example. Markdown tables rely on specific ASCII characters, namely vertical pipes for column separators and hyphens for header alignment rows. By showing the model one complete example of this structure, you anchor both the structural formatting and the exact column schema. Let me walk you through our practical example step by step. In our prompt, we supply a complete table header consisting of name, age, department, followed immediately by the separator row, and a single row of data. When we then present a paragraph of unstructured employee text, the model doesn't guess how to construct the table. It maps the incoming text directly into those 3 specific columns, replicating the exact pipe structure line by line. This guarantees that every output renders perfectly in Markdown viewers and maintains schema consistency across varying inputs.
Moving on to our next question. When extracting lists from text, how does a one-shot example prevent the model from numbering the items if you only want bullet points?
Welcome back. Today we're looking at a classic quirk of LLMs, their heavy probabilistic bias toward numbered lists. Because pre-training datasets contain millions of numbered lists, an LLM's default instinct when asked to summarize or extract points is to output 1, 2, 3. Even if you write "do not use numbers, only use bullets," the model's underlying token probabilities often lead it to output numbers anyway. To break this default preference, we leverage one-shot prompting. In transformer models, visual and structural tokens in the context window carry immense mathematical weight during output generation, often much higher than negative text instructions. When you show the model a visual template where list items begin strictly with a dash or an asterisk, you realign its generation probabilities. Let's walk through our specific example. In our prompt, we include a single target output formatted strictly as --apple, --banana, and --orange. When the model processes the actual task, it looks back at the context completion pattern. Seeing 3 consecutive lines starting with dashes, the model mathematically prioritizes generating another dash rather than a numeric token like 1. Consequently, it produces clean, non-numbered bullet points every single time, giving you exact structural control.
Moving on to our next question, how do you handle a scenario where the output format needs to change dynamically based on the input?
Hello class. Today we are discussing a crucial architectural limit of one-shot prompting, dynamic conditional output formatting. Senior prompt engineers know not only how to apply a technique, but also when not to use it. A single example inherently establishes one static output schema. If your application requirements state that input type A must yield JSON while input type B must yield XML, attempting to capture both logic branches within one single-shot example will fail. The model will become confused because it lacks sufficient examples to learn the conditional switching logic. Let me step through our example to clarify this failure mode. Imagine an application where multiple items should return a JSON list, but a single item should return a plain text string. If you provide only one example displaying the JSON list structure, the model will apply that list structure to single items as well, breaking downstream application logic expecting a string. To solve this dynamically, you have 2 professional options. First, switch to few-shot prompting, providing clear examples for each conditional branch. Second, implement an agentic router, a lightweight initial prompt that classifies the input type first, then routes the request to a dedicated prompt containing the exact one-shot example for that target format. Recognizing these limits is key to building robust systems.
Moving on to our next question, why is it important that the one-shot example's output is highly deterministic for API pipelines?
Let me focus on software integration and production pipelines. In modern system architecture, an LLM is rarely a standalone component, it is usually a node in a larger automated data processing pipeline. Data flows from a user input, into the LLM, and then directly into downstream code written in Python, TypeScript, or Go. Downstream code relies on deterministic key-value contracts. If your Python script attempts to access data, user_age, but the model improvises and returns data, age, or data, user age, your application crashes instantly with a key error. This is why strict schema adherence is vital, and one-shot prompting is our best tool to enforce it. A single clear example anchors the exact naming convention, whether that's snake_case, camel case, or fully qualified key paths. Let's trace our step-by-step example. Suppose our Python parser expects user_age. In our one-shot prompt, we provide an example output explicitly featuring user_age, 30. When the model processes new, unpredictable user text, the presence of user_age in the immediate example acts as an unshakable template. The model replicates the exact key string user_age rather than hallucinating synonyms like age or years_old. By removing key variability, your LLM functions as a deterministic API microservice.
Moving on to our next question, how do you enforce date and time formatting, like ISO 8601, using one-shot prompting?
Today we are tackling date and time standardization. Date-time parsing is notoriously brittle in software engineering. When extracting dates from unstructured text, language models natively prefer human-readable phrases like October 25, 2023 or tomorrow afternoon. However, databases and scheduling APIs strictly require standardized formats, most commonly ISO 8601 strings like YYYYMMDDTHH, MMSSC. Trying to instruct a model to use ISO 8601 by a zero-shot prompting often results in partial compliance, such as omitting time zones or using slash separators instead of hyphens. One-shot prompting solves this by providing a visual transform template. Let's walk through our concrete example to see how this works step by step. In our prompt, we provide an example input containing the natural language text tomorrow at 5 p.m. The paired example output is explicitly formatted as October 25, 2023 T 17 hours Z. Notice what the model learns from this single pair. It learns to convert relative time words into absolute calendar dates, convert 12-hour clock times into 24-hour military time, add standard T separators, and append UTC-Z time zone markers. When the model processes the actual task input, it mirrors this exact transformation logic, giving your backend perfectly parsable ISO timestamps.
Moving on to our next question, if your application requires XML output, what is the best practice for writing the one-shot example?
Welcome to our final question in this module, focusing on XML formatting. While JSON is dominant in modern web APIs, XML remains vital across legacy enterprise systems, SOAP services, and specific document processing pipelines. Unlike JSON, XML is completely unforgiving when it comes to syntax errors. A single unclosed tag or missing root wrapper causes XML parsers to throw fatal exceptions. To interface modern LLMs with enterprise XML systems, one-shot prompting is standard industry practice. The goal of your single-shot example is to demonstrate syntactical validity, explicit opening and closing tags, proper node hierarchy, and a clean root container. Let me analyze our example step by step. Our example output provides a clear root element response, containing nested elements status success/status and data 123/data, followed by the closing/response tag. When the model generates its response for new data, it replicates this strict syntax, closing every node it opens. A crucial best practice here: keep your example XML structure clean and concise. Deeply nested, overly long XML examples consume unnecessary context tokens and can induce generation errors. A lightweight, pristine XML example guarantees high accuracy when bridging modern AI models with legacy enterprise software.
Excellent. You've completed part 2 of our one-shot prompting interview series. In the next video, we'll dive into how to use one-shot prompting to lock in a specific tone, persona, and creative guardrails for AI applications. If you found this video helpful, please like, share, subscribe to SHR Trinity, and press the notification bell so you never miss our upcoming AI interview preparation videos. Thank you for watching. See you in the next video.